Let's talk about SO3 2 minus. So, yeah. All right. For this one, so our process is always, so make a good Lewis structure. So SO3 2 minus, each sulfur has 6 valence electrons. There are 3 oxygens, and each oxygen has 6. And then it's 2 minus charge, but that means add 2 more electrons because electrons are negative. And we end up with 18, 19, 20, 21, 22, 23, 24, 25, 26 electrons. And jump in anytime. Thank you. Yeah, it is 2 minus. So jump in anytime if you have any questions about this. So the sulfur is less electronegative. I haven't mentioned it yet, so let's talk about trends in electronegativity as a reminder. As you go to the left and as you go down, electronegativity decreases. Sulfur is definitely less electronegative than oxygen because it's below it. That means put sulfur in the middle, surrounded by the oxygens, connect them by single bonds. I have 2, 4, 6 electrons total in here. I'm going to keep counting now till I get to 26. 8, 10, 12. This oxygen has an octet, and so that's plenty. That's the perfect number. 14, 16, 18, 20, 22, 24. I still have 2 more electrons left. I've filled all of my octets, and so the only place to put these is in fact on the center atom. And so that's 26 electrons, and everybody has octets. I see sulfur here, so when I see sulfur, I want to do the formal charge analysis. In fact, I always want to do formal charge analysis. When I do this, and I'll do this the first time again as review, and jump in if you have any questions, but let's do the formal charge on each of the oxygens first. I say each of them because right now all of them are the same, meaning each oxygen has 1 bond and 3 pairs of electrons. Formal charge analysis says write down the number of valence electrons from the periodic table. Subtract off the number of bonds, which is 1, and the number of unshared electrons, which is 6. Is that going to be on the page? Well, equals -1. And so right now we have a minus, a minus, and a minus. Now there's 2 ways to determine what sulfur is. One of them is to do the formal charge analysis on sulfur. It too, since it's in the same column as oxygen, has 6 valence electrons. What's different is it has 3 bonds and 2 unshared electrons for a formal charge of +1. And I'll just put a plus right next to it. Now, we also could have seen, and this is a good check, if you take the charges on all the atoms and add them up, you get -2, and that is the charge on this ion, the sulfite ion. Well, that's a lot of formal charge. We try to minimize formal charge, and what we can do here is we can do an expanded octet for SO3 2- by moving one of these pairs over, and I'll cross those out and put a double bond there. Of course, the best way to do it is to redraw it. With all of its valence electrons, because a complete Lewis structure has all valence electrons. And I don't think anybody will be surprised if on exam 2 you are drawing Lewis structures And so just make sure that all your Lewis structures, you do have all the pairs of electrons. Okay, now this is as good as we can get for the formal charge. There has to be a -2 formal charge somewhere in here. Putting each of the charges on separate, relatively electronegative, high electronegativity atoms is exactly the best way to do it. Oh, and holy cow, that'll change things. I left out this pair of electrons up there. You can't do that. And what I would say, this question is not really about resonance, but there are a total of 3 resonance structures that we could draw. And if you'd like me to, let me know. But otherwise, I now have the best Lewis structure. And if I look at the central atom, there are a double bond is 1 electron group. A single bond, as we've talked about before, each of these single bonds is 1 electron group. And a pair of electrons is 1 electron group. So this one has 4 electron groups. Just like the last ones, except now, and so tetrahedral is the shape. sp3 hybridization is the hybridization on sulfur, and because there's 1 pair of electrons, we will now do less than 109.5 degrees for the bond angles. Any questions about that?